Hello, in this video we're going to look at Society of Actuary Exam P sample problem 265, and this is sourced from a Facebook page that I belong to called Etched Actuarial. And she posed the problem, because it's a lady that runs this, she posed the problem that there's 4 integers chosen without replacement from 1 to 12. Let x be the second smallest of a sample of size 4. Find the probability that x is equal, that x is equal to little x. Now the way I think about these is I create little bins. So this is the, the x, the second smallest equals this little x. So that means that, that belongs in this bin. But then there's numbers from 1 to x minus 1 that could fit in here. Only one of them fit in there. One of them goes here, and there's 2 numbers here, so you think of it as a sample of size 4. But the numbers that can go in here are x plus 1 to 12. Okay, so those are and so we want to find the possible numbers or probabilities for each bin. So let's find the probability for each bin. So here, there's only one choice that goes here. It's the number x, from here. And so here there are x minus 1 numbers left, or that are below this number, x, out of the 11 possible. So the probability that we pick one of them is x minus 1 over 11. Now here, so this is picked, this is picked. There are 10 numbers left, and we need to pick a number that's bigger than x, right? That goes here. If it's smaller than x, then it will go down here, and then that's not the second smallest. So there's 12 minus x numbers remaining out of the 10, and we're picking 1. So that's the probability. Now once that's chosen, there's only 9 numbers left, right? We have 1 here, 1 here, 1 here. And there's 11 minus x that are larger than x, that remain. So the probability of picking this one is 11 minus x over 9. Well, now if we multiply those probabilities together, we get x minus 1, 12 minus x, 11 minus x, and the product of the denominators is 990. And so that's the answer. But I wanted to introduce a distribution that's not as widely known, but I think is so powerful. And it's called the Negative Hypergeometric Distribution. And we're going to use it to solve this problem. So the setting for the Negative Hypergeometric Distribution is this. We observe one observation at a time. There's a total of m plus n observations in our population. So it's a finite population. M of them are type 1 observations. N are type 2 observations. Now we stop sampling, we observe one at a time, and we stop after we see R type 1 observations. Now R has to be less than or equal to M, right? Because we can't observe more than what we have in our sample. And the random variable x is the total number sampled. Okay, so the trick here is we need to create an equivalent problem. So let's assume we have 4 aces and 8 other cards in a randomly shuffled pack of 12. So that kind of represents the 12 numbers. Now the position of the aces in this randomly shuffled deck represents the 4 numbers that we sampled from 1 to 12. So if we have a shuffled deck, the aces could be at 1, 4, 6, and 11. And those would be the numbers. So the position of the aces represents the numbers that we sampled. So we start dealing cards one at a time until the second ace appears. And then that's the second smallest number in our sample, that position of the second ace, right? So to set it up in this problem, n is 8, m is 4, R is 2. We want to stop after the second ace. There's 4 aces. There's 8 other cards. The probability distribution for the negative hypergeometric distribution is this. So let's plug them in. So X, that we want to find the probability that a random variable is equal to little x. And the F of that really just means probability. So X we don't know, R is 2, M and N is 12, minus X, 4 minus 2, 12, choose 8. And those are combinations. Now, this here is, it's x minus 1 factorial, 1 factorial, x minus 2 factorial. And this is, 12 minus x factorial, 2 factorial, and then 10 minus x factorial. That's what we get from here. And this is just, 12 factorial divided by 8 factorial, 4 factorial. Now, when we simplify this, the 1 kind of just goes away, and all of these cancel with all of those but one of them. And all of these terms cancel with all of these but 2 of them, which are those in the top. And then we have 2 factorial. And this, the 8 factorial cancels with, those, leaves 9, 10, 11, 12. And then 4 factorial is, 4, 3, 2, 1. And then when you do the math there, so what's left over is this polynomial on top, and then the numbers multiply out to 990. And that's the same answer that we got in our first solution. Well, that's all I have for this video. Hopefully you enjoyed that. I sure did. Please like the video and subscribe so you don't miss the next one. Thanks. Oh, and a side note, I'm putting this in my actuarial playlist if you want to see more old exam questions. Thanks. Bye.